All right, so we are starting on page 97. At the very top here, we've got goals. We'll just skip over those. So planning and writing a proof. I know all of you love proofs so much. If you are given that SD is congruent to TC, and that CS is congruent to DT, you better, every time you get stuff like that, draw it, okay? So if SD, where is that? SD is this thing right here. I'm gonna mark it, it's this long hypotenuse. And then TC is the other long hypotenuse. I marked those because they were given to me. Then CS is this thing, and DT is over here. So our job is to prove that angle SCT is congruent to angle TDS. So the plan is that we are going to show the triangles are congruent, and then we can use corresponding parts of congruent triangles are congruent. Thank you. Gavin, are you here today? No. Rowan, are you here today?
No.
After class. This one's not here today though. Rowan, you have a PCCR after class. Okay, so mark the diagram at the right. Why is this thing drawn a second time? What the heck? That's weird. So we want to get that these two are congruent. I'm just going to mark that. Okay, so there's one thing that we can add as congruent on this picture. Which one? This is like the easy one. It's itself. Yeah, ST. How do we know that ST is congruent to ST? It's the same thing. They are both the same exact thing. So what theorem can we use if we've got all three sides? Oh, side, side, side. Okay, there's our whole proof. Okay, by the reflexive property of congruence, ST is congruent to ST. You can use the SSS congruence postulate to conclude that triangle TDS.
Wait, this is the.
What?
At the top it says the proof angle SCT.
Yeah. Wait, we're getting there. We're getting there. So we know that the triangles are congruent, right? If the triangles are congruent, then every single part of every single triangle that's corresponding is also congruent. Does that make sense, Maren?
Yes.
So because corresponding parts of congruent triangles are congruent, it follows that angle SCT is congruent to angle TDS. Oh boy, you should tell me when you can't see where I'm writing. All right, so next one, complete the following exercise. So you are given that angle WYX is congruent to angle ZXY. What should you always do when you are given a given? Find it, yeah, oh, it is marked, okay. So start at W, go to Y, go to X. This angle and ZXY are congruent. And then angle WXY and angle ZYX are congruent. Your job is to prove that WX, over here, I'm going to draw a question mark, is congruent to ZY, over here, my second question mark. I draw those question marks because I'm a very visual human being, and if I don't draw it, I lose track of exactly what I was trying to do. Anybody else the same way? Just me. Wow, cool, great. There's one thing that if they are touching, you have to talk about congruence. So which ones can we say are congruent right now? Yeah, Maren.
X and
XY
Y.
is congruent to XY, the reflexive property. So we will start with our givens. Step one, let's write down the givens. WYX is congruent to angle ZXY. And we can say angle WXY is congruent to angle ZYX. So over here, we would say given. All right, after that, I need to do the one that Maren just said, that YX is congruent to YX. Olivia, how do we know that those are congruent? They're the same thing. Do you remember the word for that?
Reflexive.
Reflexive, like a reflex that happens automatically, right? That's at least how I remember it. It is the most annoying. Well done, Carson. I'll try to remember it that way too. Okay, so what property of triangle congruence can we use now? I'm going to start with this single angle, then the side, then the double angle. That's angle, side, angle. Can we find the same thing on the other triangle?
Yes.
Angle, side, angle. 3, you can say triangle, that looks like an A, triangle YWX is congruent to triangle. I have to make sure I do it in the right order. Y had the single mark, so I have to do X first because it also has a single mark. W and Z and X and Y. Wait. Oh boy. Do you see where I'm getting confused?
No.
Thanks, Marion. Like that. Okay, so we know that that's true because angle, side, angle. We have an angle, side, and an angle. Yes, sir.
Why don't you put the dash on your Z's?
It's because otherwise they look like 2s, in my opinion.
They look better that way.
Thanks, Marion.
You're welcome.
You don't have to, but like I
You
will
should.
super judge you if you don't. So
So will I.
what's that? Oh, don't be judgy. That's my reminder. Sorry. I mean, but like I am really judgy, so I'm not gonna follow that rule. Okay.
Hypocrite.
No, Marion, it's called being in charge. I'm the teacher. Sorry. Okay. Last but not least, we were not trying to prove that the triangles were congruent. What were we actually trying to prove? Yes, those question marks, because remember, I'm the only person who has a hard time remembering stuff, apparently, you liars. We would say WX is congruent to ZY because corresponding parts of congruent triangles are congruent. Mr. Bodley did not give you an abbreviation for that, correct?
Huh?
No, we did CRPC.
CR.
He did not.
It's CPCTC.
Pause, we do use that like in further on mathematics, but apparently we're not using it this year. That's okay.
I've been using it all day.
Have you, or are you lying?
I've been using it to like,
Did you make it up though?
no, he put it in his notes that.
No, we did.
Yes, he did. He said CPCTC.
He very well might have. We do use that.
No, he did not. Where did
You didn't watch the video, man. You might know.
All right. Cool. Let's stop shouting. Okay. Number 2, example 2. We're on page 48, 98. I can't tell. Is it 98 or 48?
98.
Whoa, we are 98 pages into the notes. Whew. Okay, here's what we're given. Angle GMJ and angle HMJ are right angles. So GMJ, HMJ, those are right angles. GF is congruent to HF. That's already marked, but I did double check just in case I had to mark it. And angle 1 and angle 2 are congruent. Those are those top 2. Your job is to prove that angle GJM, right there, is congruent to angle HJM. So we're trying to prove that those 2 are congruent. But remember, nobody else has a hard time remembering, so you don't have to write those question marks. So here's our plan. We're going to prove that the triangles are congruent, then CPCTC to show that the sides are congruent. Oh, yay, it's fill in the blanks. So GF and blah, blah, blah that you're given. Which one is going to be for the reflexive property? Let's think about what triangles they're going to try to prove. They want to get this FGJ. So we want to have this FJ side be congruent to itself. So we are going to say, you doing okay there, sir? All right.
What do you want us to write on the plan?
Good question. Let's look up there. I skipped that part. Use the fact that corresponding parts of congruent triangles are congruent to show that angle, this is what we're actually trying to prove, GJM is congruent to angle HJM. I don't know why they gave us so much. Oh, hold on.
Hold up.
I'm trying to see why they gave us so many spaces. It doesn't seem like we'd need all these.
No, it doesn't look like
Do you even, do you really think?
Do you need what he filled
What if
in?
we just skip this one? No, I know what he filled out. I just feel like there's a lot of stuff that you don't necessarily need.
Yeah, I remember, he said that they made this longer than they should have. And
Okay.
he filled it in anyway.
Okay, well, I guess we can do that. Here's what I was thinking. This, we could just say that this is congruent to itself. So the triangles, the bigger triangles are congruent because we've got side, angle, side. And then we could say that these two angles are congruent. So, yeah, I'm going to be annoying and just skip a lot of this. So the reflexive property, we are going to say FM is congruent to FM.
Wait, I thought it was FJ.
Yep, it's J. No, it's cool. I definitely make a lot of mistakes. It's not liquid, it's tape.
Yeah, but then that one's really hard to control.
Oh, does he have liquid?
Yeah, he like painted on like, he always pauses, he goes, oh, wait.
Has to dry it off. All right, yeah, I would though. I don't like mistakes. Okay, so if those are congruent to themselves, then we can say the triangles are congruent because we have a side, an angle, and then the reflexive side. So here's the part that I don't think we need. I don't think we need any of the rest of it because we can say that I don't think that we need this FGM, and I actually kind of hate this part.
I think that was mine.
Yeah. You can just write it on this side over here because I know you don't all have tape. But we can see then that GFJ, so triangle GFJ is congruent to triangle HFJ. Because of side, angle, side. Then
Then you can skip 8, right?
yes, all of that is
What
unnecessary.
is that for?
I don't even want to think about it. So because corresponding parts of congruent triangles are congruent, we've got angle GJM is congruent to, or sorry, angle GJM is congruent to angle HJM. All right, let's look at the next proof. Okay, if you can't read my handwriting, please let me know. It's probably because it's poor. Okay, let's complete the following, oh boy, proof. Okay, let's mark everything that's given. You are given that NZY, where's N? NZY, QZY.
You can't
You're welcome. MXY, blah, blah, blah. It's basically just that these are all right angles and that YN and YQ are the same and that angle N and angle Q are the same. Your job is to prove that the triangle MYX is congruent to triangle PYX.
Why would you have an extra weird little shoot?
A weird little, this line?
No, never mind.
Okay,
What?
step one. Let's write down our givens. Oh boy, there's a lot of given. Angle NZY, angle QZY, angle MXY,
You have to write all your givens?
angle PXY. If we didn't have to, do you think I would?
Oh, well, no.
No. Are right angles. YN is congruent to YQ. And angle N is congruent to angle Q. That is all given. Make sure you number them. It's easier for me to read. Okay. The proofs, just make sure you number both sides. Every once in a while I get people who just do a really garbage job of showing their work. Step 2. What do we know if they're all right angles?
They are all congruent.
They are all congruent because all right angles are congruent. So, oh boy, next step.
Angle NZY, congruent. QZY, congruent.
I'm waiting.
What?
I thought Maren was gonna keep going.
Do you want me to keep going?
Well, I already wrote them all now.
Well, I was writing them too, I just didn't know.
So step 2 was all right angles are congruent. Too far. Okay. So if all right angles are congruent, then what do we have for triangle congruence? We want to show that these top triangles are congruent. So how do we do that? We have this angle N and Q, right? We also have these inner angles, and we have the sides. Do you see some triangle congruence on that right side? We're using one of these theorems to prove that these triangles are congruent.
What there? Oh.
SSS, SAS, ASA. Which one works?
Angle 5.
Let's check. We've got this right angle, then the curvy angle, then the side. Right angle, curved angle, side. Yes, angle, angle, side.
But I thought we were doing the N, Y, X, and.
Yes, we are. Because why could we get these angles eventually? If we know,
like vertical?
yes, we have to do vertical angles across.
Oh, that is way too much.
There's a lot of information going on here. So step 3, triangle NZY is congruent to triangle QZY. And I think it was Bailey who said angle, angle, side. Not that one, remember. No ass in math. Okay, step number 4. So because we know that those triangles were congruent, we're going to talk about these new angles. I'm going to label them 1 and 2. And then I'm going to label these ones 3 and 4 so that I can talk about them a lot more quickly. Can you read those? I know I wrote kind of like blobby with this marker. 1, 2, 3, and 4. So we know that angle 1 is congruent to angle 2.
Wait, you triangle?
Nope, I don't. I mean angle 1
Angles.
and
You
angle
went
2.
to the triangle.
Thanks, Maren.
Sorry.
How come I know that 1 and 2 are congruent? Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. All right, then let's use what we know about vertical angles. What angles are going to be congruent next?
Angle 3 and 4.
Angles 3 and 4 are not congruent yet. What is congruent to angle 1?
4.
4, because they're vertical angles. What's congruent to angle 2?
3.
3, because they're vertical angles. So angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. And it's because vertical angles are congruent. This is the proof that never ends. Okay. Don't do it. Don't do it. We've got something that we can do on the next step. A lot of congruence things. Whenever you have so many things that are congruent, you want to be thinking, what can I substitute here? So what do we want to be congruent?
4 triangles.
4 and 3. We want 4 and 3 to be congruent because then the triangles, we can talk about congruence. Right?
But we don't have another side line.
I bet we do. I bet X, Y is congruent to itself, right?
Oh, yeah. I forgot about that one.
Okay. So how do I know 3 and 4 are congruent?
Because 1 and 2 are congruent.
1 and 2 are congruent. So we know that if we were to follow this, 4 is congruent to 1, which is congruent to 2, which is congruent to 3. But I'm just going to write angle 3 is congruent to angle 4 because of substitution. You can also say the transitive property. I don't care. Step 7. Oh, this one's Carson's favorite. Reflexive property. So looking at this triangle, XY is congruent to itself. Reflexive property. And step 8. All right, we've got a side, and then what else do we have? And angles. Angles.
2 angles.
I have 2 separate angles. Do you see how the side is contained between these 2 separate angles?
Angle, side, angle.
Angle, side, angle. So we have triangle MXY is congruent to triangle PXY because of angle, side, angle. We are done
No, there's still another page.
with that one. Sorry, that was very misleading. Okay. Is there a backside of this one?
Yes.
Oh boy.
Yeah. Mr. Rowley was when you're looking at a 23 part. He just thought it was funny.
Ew, it's not funny. I hate proofs. They thought it was funny?
No. They did. They did.
Okay. I don't doubt it. Okay, the construction shows that angle GHJ bisected HK, or bisected by HK. Write a proof to verify that the construction is valid. The plan, well, we know that a bisector means that the 2 angles are congruent. That's the definition of a bisector. So we're going to show that triangle HGK is congruent to triangle HJK, then show that angle 1 and 2 are congruent. By construction, you can assume the following statements as given. So, I don't actually understand what they're asking us to prove here. So let's just get started with the given. You are given that right here. You can assume these statements. HG, thank you, and HJ, which are my initials, so they're obviously great letters. This is a G, not a 6, just poor handwriting. And then GK is congruent to JK. Okay, so how do we know that HK is congruent to HK? Reflexive. Olivia, you're getting it. I'm kidding. That's a really easy one. Okay, so do you see how none of these congruences are like marked on our actual picture? Let's do that. HG is right here. HJ is right here. GK, why is it so hard for me to say these letters? And JK, mark them. And then we just proved the reflexive, so I'm going to give it a triple mark. Who else sees what we're using? Side, side, side. Oh, so which angle can we say is congruent?
Angles 1 and 2.
1 and 2, because corresponding parts of congruent triangles are congruent. So HK bisects angle GHJ. And that is the definition of an angle bisector. So we were proving that that actually worked.
Why? It literally says it's a bisector.
I know. We are not doing this.
Okay, thank you.
Me neither.
I do. I can't see it. Do you want it?
Thanks, Olivia. We can't see it. Okay, start on your homework. Let me know if you have questions. Blah, blah, blah. Let's end this awkward notes.
Thank you, Ms. Johnson.
You're welcome.